Hi everyone, this is Jared, AC7WH, Backyard Ham Radio. Today I would like to talk about my favorite type of antenna mast and then also about circular polarization for antennas. Before I do though, I wanted to mention that you haven't seen me for a while because I've been dedicating more time to getting out and walking and getting sunshine, spending time with friends and family, and broadening my horizons, even though I really love spending time with ham radio and especially having good long QSOs, or rag chewing as it's called. I like those longer QSOs. Especially tend to like the type of conversation that I would hear on 17 meters or maybe 12 meters. I don't like the one and done, really quick type of conversations for me personally, although I realize that each person has their preference. But I appreciate more or less all aspects of the hobby, but I like being able to have a real conversation for at least 5 or 10 minutes. Then I feel like I've really put my time to good use, although it is exciting to be like, oh wow, I reached this person at 6,000 miles away, or I spoke to someone in this state I had never spoken to before, or reached a country I'd never reached before. Those sorts of things are fun, of course, but I love having just those good old-fashioned conversations. But that's my personal preference in the way I do ham radio. You do ham radio the way you do ham radio. And then, in a kind, proper way, we live and let live, right? But anyway, I would recommend that if you all have something outside of ham radio that will help build you up in every way to be stronger and better as a person and healthier overall, do so, because I feel like it's really helped me a lot. But I'm looking forward to getting back into more ham radio things now that I've kind of developed a good habit outside of ham radio as well. Okay, so as far as my antenna mast material, my favorite, if I just had to pick one really quickly, and thank you by the way everyone who commented with my previous video about antenna masts and that not so fun situation with the carbon fiber mast, that POTA 33H. Yeah, it didn't turn out so well when I tried running high power close by to that mast, as you'll see in my previous video. But it got me thinking about some things, and even though I was trusting that that antenna mast would not have any big issue with it, sure enough, it functions a lot more like metal than it would like PVC, which leads me to my next piece, which is PVC would probably be my favorite antenna mast material for portability. Obviously, if somebody needs a 100-foot tower, you're not going to make it out of PVC normally. But for something that's, a quarter wavelength on maybe 15 to 10 meters, that would be just about right for me. All right. Besides that, I do really enjoy using the wood frame, that crossbeam that Kevin made for me. You'll hear me talk about my very good friend, like family, Kevin, and their whole family have been amazing and have helped me really feel inspired and encouraged me to dive deeper into ham radio and ask great questions and have shown interest, and that helps me to learn more and to analyze things, which I love doing. Okay, so that's about the antenna mast. But with that, right now, that wood antenna mast crossbeam is what I'm using, but this antenna is actually this whole thing here, boom, not very long as you can see, that is trimmed for a quarter wavelength on 6 meters. I even have my little label there because I have multiples of similar looking wire. Now this one's pretty easy to differentiate because it's so short, but I'm going to use this as an illustration. I want to talk about circular polarization. Now, there's a few different things to keep in mind. One, if you have a circularly polarized antenna, if you have a lot of really close loops like I just made here, the way this is naturally rolling up on itself based on this spool that it was on, Well, guess what? You're making essentially a loading coil. And yes, it is going to radiate some RF energy, but a lot of your energy is just going to be powering this almost like a resistive coil. And so it would be not too much different than a dummy load, especially with a small coil diameter like this, which is just a fraction of even the quarter wavelength, which would be out to this length here. So with that, if you make a circularly polarized antenna that is spread apart more, you can do that and achieve all sorts of directional effects. But for my purposes, I want something that's not coiling up per se and generating extra inductance plus capacitance depending on how you have it arranged. I want something that for the most part is functioning like a quarter wave vertical antenna. And not only that, but I also use radials, or more technically counterpoise wires, because they are above ground height by about 1 meter or so, maybe 2 meters at the highest. And with that, I have been setting this up with a 17 meter quarter wavelength antenna in approximately a 3/4 loop. So it's not a full loop, so it's not developing that full coil, and therefore hopefully not having too much inductance. And it's not a multi-loop like I have also done before, where using that same cross beam I would have multiple loops close to each other, but then they're really coupling together inductively and so forth, and capacitively. But instead I would have something that would be about 3/4 of a loop, so something similar to this, roughly. So it's not looping over itself at all, at least in that respect. And so it's going to get some vertical polarization effects as well as some horizontal polarization effects. And because of that, when the signals are going through the ionosphere, then they're all scrambled up. And so that circularly polarized antenna that has the best of both worlds, in my hope anyway, is going to pick up those vertical elements as well as those horizontal elements. And I had a really great QSO with someone on 17 meters, and I was picking up them really strongly, they were picking up me really strongly, and it was less than ideal band conditions from what I could tell. So with that, I would highly recommend looking into PVC for antenna masts. You can get like a 10-foot PVC pipe, so that would be a little over 3 meters, for roughly $3 at like Home Depot, for example. And then you can use that to support at least a significant portion of the length of your quarter wavelength antenna, and you can make a vertical with it, or you could even get longer PVC pipes, although they do start to get flexible because they're not extremely rigid. So as far as holding their shape, that can be a challenge. But those are different options. And then of course you can do various designs where you hook them together with joints if you wanted to make more of a cross beam type antenna or more of a circular antenna. All sorts of things like that if you don't have something else that can hold it up. But if you need to just do a quick improvise and you have some 2x4 wood around, you could even use that. But just be aware, if it gets really wet or if it's not fully cured, it can conduct some electricity, even though it is somewhat of a resistor. So just be aware of that. You can start having some of the same issues I did with carbon fiber, although I would suspect that under normal circumstances, even with high power with amateur radio, you're not going to see this sort of superheating and arcing that you would with carbon fiber, but just be careful if you're using wood, especially if it's wet. PVC you don't have to worry as much about. Okay, so all that to say, I'd recommend PVC, and I'd recommend trying a new antenna design, maybe one that's 3/4 of a circle. See what you could do. See if you can get a loop or partial loop that way and get a good impedance, or use a transmatch, antenna tuner if you want to call it that, and see what you can do. I bet you can get some great QSOs and not take up much horizontal space or much vertical space because it's looping around. Just don't loop it too tightly or you'll have a nice induction coil and a semi-dummy load. Alrighty everyone, thank you so much for watching. This is AC7WH73.